A man that needs no introduction.
Thank you, Todd. Awesome. Thanks for coming out here, everyone, today, too. That was, a long trip for some of you flying out internationally, and also with the weather and everything. That was, a little bit of an adventure last night as well. So thanks for that. Also, there's a wide range of experience of folks who have come out here, too, and that's pretty cool to see, you all come out here and be able to share that kind of knowledge as well. If you're on that newer side, one of the things that might have drawn you out here that you probably heard of is things like the reliability and the resilience of Elixir, the fault tolerance, being able to build distributed systems. And if you're on the more experienced side, you might have been diving into those. You might have been able to experience that. That might have been one of the things that really drew you in and has kept you working with it as well. And of course, with Gig City Elixir, being here too, you're probably going to hear and have heard all the cool things on the website that Elixir has done. And if you're sitting here in the room today, you're probably saying, well, can I apply all of those things and get all those advantages out of my embedded system as well? And so you want to develop a product with Nerves. Well, I'm Alex. You know me as the Spark icon on the internet. Best way to get a hold of me now is typically LinkedIn. And I've been doing Nerves product development professionally for about the last 4 years now. Been doing it as a hobby for a little bit longer than that. Web development prior to that, so I've been doing that for about the last decade, and control system integration before that. The fun little project you see here on the side here is the Nerves keyboard. So that was a project where a couple web developers, Elixir devs from the community got together, and I was able to help out that group and be able to get into the hardware side of things. And this is a custom PCB, custom keyboard dev kit that came out of that. So really fun project to build there. As Todd already spoiled, I'm the current organizer of the Nerves meetup, but big thanks to Todd, I don't see where he went now, for hosting it before me, and obviously now for hosting the conference now. That's a lot of work to put on, so that's awesome. Last Wednesday of the month, and check it out on meetup.com. It's 6 p.m. Pacific time, but Meetup will convert the time zone for you for your spot in the world, which always throws off Lars's newsletter, so just use the website. Yeah.
It tells me it's the wrong day.
Yes, exactly. I think you're in, I forget if it's yesterday or tomorrow, but yes. So I've really taken the experience from being able to do this for, a culmination of experience there for the last handful of years with Nerves and also on the website too. And I've learned a good chunk of things during that process and kind of been able to develop methodologies and processes that I like to use, and took that to Found Redwire Labs here to be able to do product development professionally and help folks out with that. So let's dive into a little bit about the typical Nerves product that I've worked on. It's kind of the stereotypical one here, but I will take some real pictures of one. So there's an example of a product I've worked on. And it starts out kind of like this from the outside, typical commercial thing you'd see, industrial design, bunch of fun stuff inside of it. So if we remove the cover there and start looking inside, you've got Nerves on a firmware bundle that runs on the processor. Processor happens to live inside under that metal can there, but just picture a chip under there. But it doesn't quite stop there for a commercial product either. So we've got all the other stuff around here as well. So this is a custom circuit board, which is pretty common for anything commercial. And so that other side of the Nerves puzzle is not just necessarily like the Elixir application running on the processor, but all of that other stuff that you have to deal with, all those other peripherals that tie into the system. So I like to look at this as a kind of broad breakdown between two layers of Nerves. One is the Nerves application itself. I'd call this Elixir land. That's things where your business logic are going to live, OTP for your supervision, your application trees, stuff like that. And also things like your cloud connectivity that aren't really like baked into the hardware. It's talking to a web server, using a WebSocket, using MQTT, something like that. You don't necessarily need the underlying hardware to be able to do that part. Next part then is the nerve system. And that's really how you get the rest of that hardware working. In this section, you're going to be spending a lot more time in things like C. This is the land of Linux. This is where the bootloader lives. This is where the drivers live. So once you drop down into that layer, you're kind of leaving a lot of the Elixir territory there. So let's jump into some of the tooling that I've liked to use for projects and some of the stuff that stands out here, and some other fun things to show off here. But we'll jump into the nerve system side first. And so when you're looking around at nerve systems, the first place to go is the official nerve systems. These are great. They're on the Nerves website. These are typically maintained by Frank and John, so big thanks to them for that. And they also have a lot of community contributions to them too. So if you're working off these systems, if you've got a change or some maintenance or a patch or something, those funnel right up into these too. The caveat to this page is it's a little bit raspberry flavored. And so that's been a theme of the conference as well here. We've heard a lot of talks about that stuff as well. So Raspberry Pi, I should say, is good for getting started. We've heard that. Being able to do small scale projects, being able to do hobby projects, being able to do prototyping, and kind of like I guess I could call it like light scale commercial work, being able to launch a couple products, try something out, maybe get it into the hands of some users, do some testing for that. But at least in my experience, the Raspberry Pi flavored systems are not great at scale. So it's hard to be able to launch a product with like 100,000 devices that are all running on a Raspberry Pi. And I'll get into it a little bit more, hopefully not too much, but it comes down to basically like the cost of the product, and it doesn't end up being very economical. So when you're in that situation, what other options do you have available? The first one, which is on that official nerve system list, is the AM335 from Texas Instruments. And really, this is more or less known as the BeagleBone Black. And you might be saying, this sure does still look a lot like a Raspberry Pi to me. But there's a catch. This is an open hardware design, so this is published by BeagleBoard. It's on their website. And that saves a lot of time for being able to use or replicate all the hardware on there. And so especially where that comes into play is how you're tying in like the processor to the RAM, for example. So that's a high-speed interface, high-speed electrical interface. And there's electrical design in that can take time to get right. So to be able to shortcut that process, you can go grab the reference design for this off the website that has the schematics and the PCB layout and literally copy-paste that section of circuitry. And then spend your time building the low-speed, lower risk peripherals on top of that. If you need to go further than that, Octavo also has a SIP available. So this is a handful of these chips here, all packaged into one package. And again, that's another one of those things that can save you some design time. You get more in one package and less that you have to design out yourself, at least as far as the critical components go. So if that still doesn't work for you, there's more. So the microchip SAM-A5D27, this happens to live inside the GridPoint controller that Ben was talking about, both controllers actually. And so this is where that system started from. This is a system that I picked up maintenance for, I forget exactly when, but before I started at GridPoint. And this one's cool for certain applications, and like the controllers are a good one there. So this is a like more lower powered gateway, half a gigahertz here, 500 megahertz. So it doesn't have a whole lot of horsepower behind it, but it has enough to basically like crunch your data and get it to the cloud, and do a handful of others. It can actually run a touch screen too, thanks to John's work on the Sino Cairo driver. That's been really nice. So it doesn't have 3D graphic acceleration built into it, but thanks to John, the 2D parts of that got up to speed enough to where it can run a touchscreen there. The cool thing about this one, kind of like the other system too, the AM335, is this does come in a microprocessor or a SOM. So the microprocessor is the chip there on the board. The SOM is that whole square, and it's got all those goodies in the middle on it. So the cool thing about that is it's got Wi-Fi and I think it's got the RAM and a handful of other things. It's also got the crypto chip that Lars was talking about on there too. So that can be another one of those solutions for something like that where you might not want to have the crypto chip with the pins hanging off the side because somebody could probe into those and start getting the keys off there and stuff like that, exactly like what Lars was saying. So having that in a chip that's really hard, a lot harder to probe, and already in that module is something that can potentially be an option for one of those types of cases. The economical difference of why you'd want to be looking at this too is the SOM is going to give you a higher BOM cost. So it's more to buy that section there. But because it's got more stuff on it, it costs less in design time and NRE cost to engineer that. If you need to scale up into higher volumes, get the microprocessor because that's cheaper on the BOM, but you'll have to spend a little more time integrating all the other components into the system. So that's one good place to start. Another thing to take a look at here is the Texas Instruments AM62. And the best way I can describe this is I think this thing is just a unicorn. It has just about everything on it that I've been looking for in a chip here. So really excited to see this one come out from Texas Instruments. This thing can go from 1 to 4 1.4 gigahertz CPUs. So depending on the SKU that you order, you can get it single, dual, or quad core. You can get it with or without that 3D graphics accelerator. Lars already spoiled that it comes with Trust Zone. He already weaseled that out of the audience earlier. So that's amazing because Trust Zone is one of those things that can start replacing the crypto chip potentially here. And it's also got, I think it was like 2 HDMI ports, so it does dual 1080p outputs. It's got some really cool stuff on it. So this is one of those things that can work its way up into like those higher powered type of gateways, higher powered applications, start getting into kind of the edge computing type stuff. I'll say the caveat to this though is it doesn't have like an AI ML core on it. That's in, if I remember correctly, I think the AM67, which I'll say I'm also interested in, but when I was talking to, I don't know if I can say that part. I'll just say I have high hopes for the AM67. Maybe it will come soon. But anyway, we've got support for this right now to where it's booting into Linux. This is up on the web right now. It's not booting in Trust Zone. It's booting without Trust Zone, so just unencrypted. It'll get you into the console, and we still have work to do on the peripherals on it as well. But you can at least get a Nerves console up on this right now. And for a commercial project on this, it's, you do out the rest of the work on there. But as we can add this to the open source side, we'll be expanding on that as we can. And if you still haven't seen a platform here that you like, you can create a custom Nerve system yourself. Basically, prerequisites for that are make sure that it's running a modern Linux kernel, so basically something version 5 or higher. Ideally, if the vendor provides build root board support for it, that's amazing. That'll port over usually pretty easily. If they provide Yocto, you're not out of luck. It's just going to take more work to get that through the finish line, but it's typically possible. So now that we've talked about that underlying hardware, what if we could switch between pieces of hardware? And to contrast that a little bit, one of the ways that this, I've heard this story go for some folks, is the SD card swapping process, I'll call it that. So developing the firmware on your computer, burning to the SD card, taking the SD card out, plug it into the development kit, find out it doesn't work, rinse and repeat, right? And then once it works, ship it. But a lot of you have probably been doing software for long enough where you know about software best practices, writing unit tests, being able to have an iterative development process, all that kind of stuff, simulate your things, all that. So the way that this could look is, what if you got your firmware up here that you've written? And first of all, you're writing your unit tests for it. And those are compiling locally on your development machine, and you're able to get that faster iteration cycle there. And then maybe you're able to start it up and run it in the console on your dev machine. And then you're able to start working with things that don't necessarily require like that hardware side. So you can start testing things like your cloud connection, start testing that you're making sure that you're getting up to your MQTT broker, things like that. And now maybe by that time, you or your company have selected the dev kit that you want to use. That stuff has shipping time on it, so maybe it hasn't come in yet, maybe you gotta wait a little bit for that. You finally get the dev kit, and now you're able to drop your firmware on the dev kit. And then as part of that hardware development process, you typically have a couple iterations of hardware before you actually get to production hardware, right? So you gotta go through like a Proto 1, Proto 2, make sure that all that works before you actually ship it out to your customers. That hardware doesn't have the same stuff on it or isn't wired the same way as your dev kit is. So now you need to be able to run the firmware on the prototype hardware, and eventually you get all that ironed out, and now you need to run it on your production hardware. So kind of whole hardware life cycle here. So a library that I've got that I like to work with for this is Resolve. So this handles dependency injection either at compile time or runtime. It's not the only way to do dependency injection. Obviously, you can use your own method if you like it better. But this is basically a way to have a caller, some part of your code that needs to do something, call into a module, and in this case, we'll say we want to get the serial number of we'll say of the firmware. Now, depending on what platform that firmware is running on, that get serial number function is going to need to do a couple different things. So if you're running on your real hardware, maybe you're getting that identity from that cryptography chip, from that ATEC chip, like that Lars was talking about. But now you also need to run it on your dev computer, on your host, to test some things out. And that doesn't have the crypto chip, right? So now what does getting the serial number do? Well, in that case, you could have it point to, say, the file system, with a file that has some serial number representing your computer, and now that can talk to the cloud that way. And you can actually use the firmware in your console on your computer as if it was on a board, and it's still talking to the cloud, and the cloud doesn't know the difference. And then for your unit tests, obviously unit tests are unit tests. You just kind of want those in memory, and you want to be able to throw the inputs and the outputs away when you're done with them. So don't bother storing it on the file system, just keep it in memory, and that works for your tests. So the whole goal behind this is really figuring out which module do you put in here, depending on which environment you're in. So the way that this looks in code is a couple little key pieces here. Number one, use resolve, the magic little macro there. And really the bulk of it is right here. You call resolve and you pass in that source module, that original module, that you want to be able to inject over top of. And if you don't inject over top of it, it just defaults to whatever this module actually is. So in this case, it would just be my interface here. The rest of this code is basically a little proxy pattern that I like to use. And you don't have to use this, your mileage may vary, but this can help out where if you want kind of like a facade or basically like a proxy like module in front of that, so you only have to worry about calling my interface.sum command, and you don't have to worry about like this will hide the rest of the stuff from the caller. Just write some little wrappers here. And so define your command, say resolve it to whatever module, and call it again here. I think def delegate, if I remember right, is kind of like the Elixir equivalent, but you don't get this little magic piece in the middle, so you can kind of think of it that way. And that's it. The catch to this that you should probably know about is if in this code, if this is not injected into anything and this is my interface, some command calls some command and this deadlocks, but that's not necessarily a bad thing because you know you didn't set the mapping up right if it deadlocks. That's one of the things that I could put some quality of life stuff around that at some point. That'll probably help. Just haven't had time to get there yet. So I mentioned this could be used at compile time or runtime. And really, the environment you're in is probably going to dictate which one you want to use. So if you're in production or you're basically your firmware is compiled down to one of your hardware targets, then you probably want to use the configuration here that compiles your mappings down into the code, into those Beam files. And in one of those EXS files, typically per environment, you've got a list of mappings here, and you just take your original module and say which one you want to inject it with, and you just got a big list of those in the config. One of the cool things you can do with this at runtime, which is basically once you're working with your unit tests, is you have resolve inject as a function. And this can take an original module and an injected module as two arguments. But one of the really cool things you can do is in your tests, yes, you can write factories, but those kind of end up separated in other parts of your code. They end up in other file, in another folder, in other files. They're not necessarily next to the pieces being tested. Sometimes that's okay. Like if you have a whole bunch of stuff that's using, one of those fixtures, yeah, that might make sense. But what happens if you've got something where you're just trying to test one input changing here and there, and then the other input changing here and there, and you don't really want a bunch of factories hanging around for that? Well, with Resolve, inject it straight in. So just do a little quote block here. This builds an anonymous module, and that module that gets injected is going to have the open, close, and command functions here that you can use. It'll run those for your test, and it'll throw them away. So now that we've kind of talked about switching out the underlying parts of the system, what about the stuff coming into the system? And a little bit of a preface before I dive into the top part is let's actually quickly talk about the bottom part of how things get stored, because sometimes that can govern the inputs, especially if you're used to Ecto, for example. That kind of has a database schema that flows throughout your system. There are a handful of ways that you can deal with storage on an embedded device. And when you're looking at this slide, I like to think of it as kind of working from left to right and moving to the right as soon as you've kind of hit the bounds of what the thing on the left can't really do well anymore once you start feeling a lot of friction with it. So number one, start with discrete files. Like the file system in Linux kind of is a database. You've got a folder structure, you've got different files you can put stuff in. You can have plain text files. You can even put structure in your files. You can put JSON in your files. You can dump Erlang term format in your files and read and write Elixir binaries in there and just have them come right back up into Elixir as the same Elixir primitives and stuff that you dumped into them. But there are some limits that you end up hitting, with files. One of those things is dealing with key value storage and dealing with PubSub. So that might be the time when you start getting to that point where you want to move to property table, which is a little kind of type of database you could kind of think of it as that comes along with Nerves. So also nice to be able to use it from that perspective too. So key value storage, pretty easy to work with. It's in memory by default, but it's got a flag that you can persist it. So if you need it on disk, just flip that flag. And it's also got PubSub that comes along with it too. So it's a great example actually is it's used in Nerves for VintageNet for being able to set your networking settings, IP addresses, gateway, subnet mask, stuff like that. And so so number one, you've got that data as key values that you could go pull stuff, push stuff in, pull stuff out from. The subscription mechanism comes in handy there because what happens when your network interface goes up and down and you want to know about that? Well, now you can subscribe to that property. So another cool tool built into Nerves that you can leverage right there for when you need to do storage. When you start pushing the boundaries of that and you kind of start needing to have that like more traditional database feel, and here I don't necessarily mean like relational database yet, but you want things like transactions. And you might need things like more resiliency on disk. So like what happens in case of a power failure? If something's being written to your database and power's lost on your embedded device because the user pulls the plug on it, what happens in that case? And so at that point, that can be a good time to start looking at something like CubDB that handles a lot of that. And then once you kind of push the bounds of that, so like if you actually get to the point where you need a full-blown relational database in your embedded system, you're working with data of that complexity. Then you probably want to take a look at something like SQLite next. And in practice, I've typically found that like most of my time at least ends up being, or like most of our challenges end up being solved between typically CubDB and property table. You can do a lot with those tools right there. So I've got spec. This is a way to do input validation. It's designed to be lightweight. It's designed to help document your protocol. And it's also kind of nice for embedded systems, and I kind of put that in there because if you're not up to the relational database side of things yet, where it makes sense to drop Ecto in, maybe you don't want to go as far as dropping Ecto into your system yet. And so in that case, well, what do you use? The other thing I like about this is it really breaks up validation into a discrete layer. So spec really doesn't have anything to do with the storage part. It's all about what happens to that data coming in, how do we make sure that data is okay to use in the rest of the system, and then just let it flow to the rest of the system and be hands-off at that point. So the way that this looks is up in that validation layer. Let's say we're working with MQTT. We might have some events coming over the wire like add device and remove device, and we need to validate those messages. We get these back as valid messages then we need to go off and do something with them. So then that business logic or that model layer or that context layer in Phoenix terms, we'll have something like a device that comes out of that after we've, say, added one. So a good way to look at these layers is that validation layer is really dealing with things like verbs. These are those actions. You're adding, you're removing, you may be sending telemetry or receiving. That model layer, you're typically working with nouns. So like this is a device, this is a sensor, things like that. So if you start noticing the line blurring between these, that could start being one of those warning signs that maybe these layers are starting to blend together and there's a better way to start separating those. This is an example of what the schema looks like. And so I mentioned documentation as one of the goals of this as well. And so this was designed to be easy to read, also from the context of somebody that doesn't necessarily know Elixir. So when you're working in a commercial project, you might have to interface with other teams. You might have to send up information to web developers. You might have to send it down to firmware engineers working with microcontrollers that you have to interface with. And so part of bridging that language gap is honestly trying to remove some of the language out of this and generalizing it in terms that are just general programming terms that a lot of folks understand. So up here, we've got a struct. This is a little bit of Elixir specialty, but basically we're just saying, hey, we want that add device struct to come out of this. This is not really opinionated at this point, so if we want to version the protocol here, we can, and say this is going to be version 1 of add device. And if we need to extend that to a V2 later, not a problem, just copy paste this and do a V2 and add whatever you need to add. Name is an optional field, and so this could be over the wire. So this could be like the MQTT topic, add device in this case. So there might be some other stuff prefacing that in MQTT land. And then your attributes. And I won't go over this because you probably already know this all already. But that's basically your primitives and validating it with regular expressions or enums or min-max and length and optionals and all that kind of fun stuff. And you can also nest everything. So what this looks like in the code then to do the actual validation is you'll typically have a part in your software that message is coming into. So if you're working with like WebSockets, this could be a WebSocket event handler. If you're working with MQTT, this could be like Tortoise's event handler. You're going to have something that typically triggers here, some event with some parameters or that message that comes into it. And from that point, just call spec.validate, pass it the schema, pass it the params. And all this probably looks pretty typical for Elixir at this point. Just get into your business logic, say, okay, now that we have a valid device here, create the device. And we can take that message ID and RS-485 address to do that. And if you've got errors, you end up with a list of errors. So now that we've gone through a little bit of the tools, whose hands do you put those tools in? And you've already heard this theme here today, but I'll go over it again. One of the concepts, I felt like I had the concept of this at some point, but it's not original at this point, is what if you can take Elixir and use that throughout your stack? So typically you've got a back-end engineer. They're probably working in Elixir since we all love that. Front-end engineer, they might be working in JavaScript and React or something. Firmware engineer, C. DevOps might be working with Bash and Terraform and Ansible and those kind of things. And so what if you were able to help unify these disciplines or tie them together with a thread that's kind of like Elixir is that thread that helps unify this stack? And Lars actually published an article for this for me, cross-cutting Elixir teams on Lars's blog, if you check that out. Thank you, Lars. And this was a really cool concept. And I think I got most of it right in hindsight, but there's definitely one big caveat to this, and Pal also touched on it, and that's domain knowledge. So what this doesn't account for is what's not the language, what's not in the language that these other disciplines know. So, for example, that front-end engineer probably knows how to work with Figma and pull properties out of that and make pretty-looking components. The front-end engineer doesn't know how to read a data sheet. And Elixir doesn't solve that part of the problem. So one of those things here, kind of like talking about that data sheet, is some of the things you need to know going into firmware if you're doing that part of the discipline are the tools that come along with that discipline. And so at this point, it's more than just software. There's a good portion of software that you have to work with. But you should also know and be able to work with things, like a multimeter, like an oscilloscope. You should probably have a good power supply, because how many times do power problems cause intermittent issues or flaky issues, or actually the Raspberry Pi power cable is a good example of that. I can't quite remember it yet, but I see head nodding, so you all know what I'm talking about. You get the wrong cable for the Raspberry Pi, basically, and it doesn't work. It doesn't power on. And soldering can also be good to know, too, a little bit. So some things are physical issues with your hardware that you're just not going to be able to fix or troubleshoot in software. And so if you can do some of those mods yourself, especially in a remote culture, that can help save those cycles from having to go to an electrical engineer or ship your board off or put it on their desk and wait for the turnaround for them to deal with it. And so not that you have to be a total expert on this, but if you know a little bit about this, it can help guide you towards the right places. So I think a good example of this would be like that case of troubleshooting. And so if you're on the software side, one of the places that you're used to troubleshooting, one of the things that's going to be familiar is using the console or using the logs, cloud logs, for example. But we'll say you've got logs coming from your system and you can visualize those somehow. And so when you've got something that goes wrong with your system, you look at the logs, you see what the problem was, go through the backtrace and fix the problem. The thing that I've seen trip folks up coming into firmware is being really reliant on that console, because that's what you're used to go for to see your problems, right? And overlooking some of the tooling. So, for example, if you've got access to say a multimeter and you're having a problem, you might not be seeing anything in the console. You're just flipping bits, seeing what works. But if you've got another tool, if you've got something that gives you a different type of visibility into the problem, when you go look at part of the circuit, say you're looking at the voltage coming into a chip, and you see 0 volts, well, that's not something you're necessarily going to be able to see from the console, ignoring Pal's awesome example of his live view thing. But this is going to show you, okay, I have a physical problem with my board. I'm not getting power to this chip, which is why I don't see that chip on the I2C bus, or why I'm not able to read and write from it. So that could be something to really look at there, of just understanding those other tools that are available, getting used to them, and yeah, familiarity can really help. Also, doing firmware professionally, as a firmware engineer, you're going to end up having to work pretty closely with your electrical engineer or your team of electrical engineers. And so, number one, knowing things like being able to read the data sheets will really be able to help you in doing your job of writing the drivers that make the component on the data sheet work. The other thing is being able to read the schematics, or at least the important parts of the schematics that come back from the electrical engineers, because this tells you how to wire everything up, where everything is. This is kind of like your map of the system. And I'll take that a step further too, where this is one of those things where you should be collaborating with your electrical engineer on this as well, because you have the ability to influence this design. If something doesn't work out right or doesn't make sense to wire up one way or put in part of the circuit one way, you can change that before the hardware actually gets made. So having that hardware and firmware collaboration to make sure you're actually building a product that's easy to develop. I'll throw in here too, actually, I'll say if you're a really good firmware engineer, if you're really going that extra mile, it's awesome if you can review and give feedback to the electrical engineer, basically being able to do a schematic review for them as well. Because this is really like the equivalent of a code review for your electrical engineer. And typically they don't normally have a lot of folks in that department. Maybe it's one or two EEs you're working with. So the extra eyes on that can be really helpful for them as well. So kind of wrapping all this up, some of the strategies I've seen for success to boil this down is, number one, resourcing what I'd call full stack engineers, which is kind of the typical way that folks have been looking at it so far in the community. And I'll define full stack in this sense as like front end to FPGA. So I didn't mean like front end to back end, but like a pretty wide range of the stack, right? The challenge here is these folks tend to be somewhat of unicorns. It takes a long time to get to that point. So if you can find these folks, they're absolutely great. If you have a larger team or you've got a resourcing crunch, you might just not be able to do it this way. And so what other options do you have available? Well, the other one is cross-training C engineers to Elixir. And like this is what Ben talked about for what I jumped into the GridPoint team and did. And that worked out really well. So you're taking this problem from starting with the domain knowledge of these folks know the domain, let's get them into the language. And so you're able to take that from the opposite perspective there. And then the third thing, go hire a guide. Get someone who's done this before. Go get a product development agency, go find a consultancy. they've seen a lot of things that do and don't work. And for a commercial project, they can really shortcut a lot of pain. So, that being said, what questions do you have for me? Uh-oh, not Ben.
This isn't a hard one, I hope. I may have just blanked out for a couple seconds when you were talking. You know it happens all the time. In your opinion, what is the barrier between using property table for your DB and using CubDB for your DB? I am thinking about this for my work, so I want the answer to this.
That is the answer. That is the question you should be asking yourself every day when you're staring at that code. It's going to depend on your project. You know me too well because that's actually what I throw back. Yes. But that's seriously the answer. This isn't like a one-size-fits-all thing. You really need to be thinking about your code base and being in tune with what you're feeling about the code. So like, am I feeling that pain point where this method just doesn't feel like it's working for me? Does it feel like I'm fighting against this? If the answer is no, don't change it. Keep doing what you're doing. If you are feeling that, that might be time to move to the next step. But then think that step through. So, you know.
I guess I was wondering, what are the pain points that would cause one to consider such a jump?
Oh, what are the pain? That can also vary per project.
For real, man? Come on.
I'm going to give you the consulting answer, Ben. It depends.
Yeah, I've heard that one 1,000 times.
Yeah, it really does, though. It's all project dependent. It depends on the project and depends on the team.
How much are you charging then for a straight answer?
Contact me for my rates.
It's not a question, just when you find yourself writing your own query language, maybe you should be using a query language.
Yes. Anybody else? Anybody from either the head nodders or anybody who wasn't nodding? Anyone want to tell me how wrong I am? Oh, okay, cool, Greg.
The third option, looking for firms that can help you develop your platform.
Yep.
How, I mean, I'm new to the Nerves environment, as you know. How many firms are out there doing that? I know you're obviously doing that yourself, and how would you decide whether these firms are capable of Nerves versus they've been doing other projects?
Yeah, great question. I don't know if that picked it up on the mic, so I'll kind of repeat it a bit. So how do you go about looking for consultancy? What are you screening them for? How do you really know they can do Nerves? How many other folks are out there? I'll just start answering those in a random order. The good news is if you're here today, now I back up and start with another one. So one of the big reasons why I got into it was having a difficulty in finding a place to go to that already does this in, that's capable of doing it well and it also in a way that I like and promote doing it. Now, the big caveat to that is the second one, is my personal preference. So there are some other places out there that may just not do it in my style, but are still great to look at. So the next place to look is, there are a handful of those other places in this room. So if you're at this conference, go network with them. I'll just call Lars out, is awesome, especially since he's got the newsletter, so like chat with Lars. But there's a handful of other folks in this room that do that. That's a great place to look. So you can find people on, basically in the community through the other community channels. You can find stuff on the Elixir forum. You can find it in Slack and Discord for Elixir, that kind of stuff. Quality is a tricky one. That might literally be the $1 million question right now, because I've seen some projects who have lost that amount or more trying to fix things. So I'm trying to think of what the answer to that is. There's a certain vetting process. It probably goes back to the slide of doing the vetting of the language plus the domain knowledge, because probably the temptation coming from the Elixir space is only vetting on Elixir. That's probably the biggest thing I've seen so far. And so I'd probably say if you're vetting a firm, look for how well they actually know the hardware side as well if they're building your hardware. Did I answer all your points, Greg, or do you have any more? No, this was good. Okay. Yeah, that's right. It depends. That's my go-to line. Yeah, exactly. Anyone else? Lars just smiled. Lars, do you have a question? No. You, okay.
I'm just waiting to give you applause.
Okay. Thank you.